All right.
I wanted to contribute to the food at my house.
This is the kind of the other half of trig. So the first lesson we did was just kind of within triangles and enclosed angles. So that's like kind of half a trig. The other half of trig is going to be this, which is angles of rotation. Those are the main, what I view as the main parts of trig. I'm not even sure if you've done these before or not. Not that it's horribly hard to understand. Why didn't it change slide? There we go. These are called angles of rotation. Have you done these before? Yeah, I didn't think they'd be in geometry, but I wasn't sure. Okay. I mean, it's still dealing with angles, so it's not terrible. What really is going to matter, the reason I ask, is kind of how fast I should go through it. Now what's most likely going to happen is we'll just take today to go through the notes. Tomorrow we'll start the notes on the next portion of trig, and then I'll probably give you the homework for Friday, like on both sections. Oh wait, you guys, yeah, okay, we don't meet Thursday, sorry. Yeah, my brain's working too fast.
Slow it down.
Yep, I'm not here Thursday, so you guys will watch the video on Thursday of teaching the third lesson. So make sure you guys bring headphones or whatever you need to be able to watch the video in class. That's probably by far the easiest setup, is just to be able to watch it in class so you have time for it. So angles of rotation usually will start on the right-hand side like that. They don't have to, like navigation for pilots and whatever. They don't start on the right-hand side, they start facing up. But virtually everything you're going to do, it's going to start on the right-hand side like that. So the initial side will traditionally always be right there. And then wherever it stops is just called the terminal side. Like, I'm not even worried that you guys know the terms. Just the fact that you get that a whole point of a rotational angle means that it turns until it stops. And then we measure how far it has turned. That's the whole point about rotational. It just means it moved. What's going to be similar, since you haven't done these before, what's going to be similar to, like, say, geometry is you guys, I'm sure everybody by now knows that 90 degrees makes the L shape. So 90 degrees would be straight up. That'd be a rotational angle of 90. 180 would be look like a straight line. So that's going to be the same. But then what probably is different from geometry is you can keep going past that. And it's the same measurement constantly. Each axis is 90 degrees. I don't know. Anything about there you want to ask about?
What are those set of notes called? So I can type it.
Rotational angles, I think. I think that's what I wrote. Okay. So this is kind of what I just said out loud. If you start here, that's known as 0 degrees. Turning counterclockwise is going to be positive. So that's 90, 180, 270, 360. And you can keep turning as much as you want. Like there is no limit to rotational angles. Oh, I forgot to draw an arrow. Coterminal angles, that is a word you'll need to know. Coterminal just means that it's two angles that are at the same location. Because you can keep rotating as often as you want or as far as you want, frequently you'll run into two of them that stop at the same location. Like 0 degrees and 360 degrees both mean to the right. Same with 720. If you're asked to find a coterminal angle, you can add or subtract 360 as much as you want. And that's just how you find a coterminal angle. I think most of you guys are probably pretty familiar with, between like, I'm trying to think of the different sports. Between skateboarding, snowboarding, skiing, the various sports where you do rotations. Figure skating. No, they don't call it that in figure skating, though, do they? Don't they call that an axle? Like a double axle, triple axle? Is anybody here a figure skater? Okay, then. Oh,
I am.
oh, so you know the terms.
I'm majestic on that.
I see.
Yeah.
But either way, like I think most of you know that a 360 means you turn once. And the whole idea is that you're facing the exact same direction when you stop. So if you're going forward and you do a 360, it means you spin one complete time in the air and you land the same direction you were before. That's kind of the idea of coterminal. It means you're at the same spot even though you've rotated. So it's like a 720 would mean you would do 2 full rotations but still land forward. I don't know. I didn't know the best way to draw that picture, to be honest. I don't know if that picture makes sense. Is it okay? Do you guys think you could draw a 495-degree rotation? Otherwise, I can draw it with you. Is that something you want me to draw with you to start with? Okay. So I'm going to draw my initial side first. 495 degrees. So I'm going to go 90, 180, 270, 360, 450, and then 495. How much more than 450 is that? 45 more. So 45 is a half. 45 is the midway point between the axes. So this would be a 495-degree rotation. And I know that symbol looks stupid. That's fine. But that would be like an easy way for you to show that you've rotated more than one complete circle. Mm-hmm.
So we'd wanna like show the circle stuff like going around.
It's a good question. I would to start with, so that your brain gets the idea of what you're doing. Later on, it won't matter how many times we've turned. So, I mean, like, for right now, I think it's a good idea. Hi.
Good morning.
Good morning. If I asked you guys to find a coterminal angle for 495. Oh, we should roll. Who's the one that has to roll? Oh, multiple people.
Go ahead. No, you should.
I do remember you saying that the other day, though, didn't you?
No, no, no,
We got lots of days left.
yeah, I know.
You guys figure it out.
You asked me to shoot it.
No, seriously, it's
I
fine.
gave, I gave him the castle. The skull crusher.
The school question.
So the pyramid one,
We have a question. So, when you go around, I know it's 360 degrees, but is each of like this
90.
squares, are those each 90?
So the pyramid one, you read the top.
sorry?
You read the top
The top one.
because all the numbers line up at each corner. I know, it took me a little while to figure it out too.
Okay, row 1, seat 4.
Is that David? If I want to find something that's coterminal to 495 degrees, how do I figure that out? It is highlighted in yellow. I can scroll down.
You can add or subtract 360.
Okay.
As many times as you want.
Well, I know you can read. I was waiting for you to tell me how to figure it out from 495. You did just say it out loud.
You just subtract 360.
Perfect. So you can either add or subtract. I'm assuming most people would subtract to make it smaller, just because the number would be easier. So what do we have? 135. A 135 degree angle would be coterminal to 495. If you wanted to make it bigger, you could have added 360. Sometimes you're going to be asked to find one positive coterminal angle and one negative coterminal angle. And so if that was the case, I would want to subtract 360 again, and then that would go into the negatives. Okay, and once you figure out, just like yesterday's assignment, once you figure out what to do, the questions are quick and they're easy, but it's not a simple step of getting to the once you know what you're doing. Like there's a lot of things of trig to explain. It takes longer to explain than to do.
What do we do with the coterminal? Like, do we have to graph it?
Nope. Well, if we did, it would just look exactly like that one because coterminal means it's pointing the same direction. Like if I draw it in a different color, 135 degree rotational angle would look like that, just with less turns. It would be the exact same spot. That's that's the whole idea of what coterminal means.
Two things. One, if you get an even bigger number, do you have to list all of the coterminals or just one?
You're usually just asked to write one,
Okay.
and there's lots of correct answers.
Okay. Second thing, do you have a tissue?
Yes.
Okay.
I stole some from Sarge. Okay. Just like when we went counterclockwise, those are considered positive rotations. Clockwise is negative. It definitely bothers me that clockwise is negative, but I don't get to choose. Everything always seems to go by clockwise, like taking turns in cards, whatever. Clockwise is what everybody's used to, but when you're counting up degrees, that's negative. So negative rotations work identical to positive, it's just you count up in the negatives. And then if you guys can, after drawing the first one together, see if you can draw a negative 300-degree angle. You weren't late. I was.
What do you call that?
Yeah,
Row 4, C2.
Lucas. Do you think you could describe to me how to draw a negative 300-degree angle?
Yeah. You draw a line on the base to the right, and then you go around from the bottom, clockwise,
Mm-hmm.
all the way to 270, and then you go a little past
Where is it going to end up?
it. Like the top right.
Perfect. That's good. That's good explanation. So you would rotate 90, 180, 270, and then it's only going to be 30 degrees more and end up right there in the upper right-hand quadrant. If you guys remember, that's quadrant 1. Okay, good. Oh, you know what? I forgot to put that.
Does quadrant 1 relate to the Q1, Q2, Q3?
Yes. Wait, are you talking about box and whisker plot, Q1, Q2, 3?
Yeah.
No.
No.
The Q stands for quadrant. On those, it's quartile, but it just means things are broken up into 4. So I guess that's how they're related, other than it's not like they're the... It just means it's broken up into 4.
Does like the bottom arrow in zero, like, does that always go to the right?
Yes.
Okay.
Yeah, for us, yes, it will. Okay, one more person.
Row 1, C8.
Do you think you could give me a co-terminal angle to negative 300? Yep, I heard you whispering it.
60.
If I add 360 onto negative 300, I would get positive 60. So that would mean that if I draw a 60-degree angle, it would end up at the exact, oh, that's pretty bad. It would end up at the same location. So the whole thing about the degrees, it just means which way you're turning and how far. Yeah.
On the test, do we have to draw the little like circle and put the 60 like, in between the angle, or can we just write?
I guess it depends on the question.
Okay.
So if I ask you to draw like a negative 300-degree angle, the little circle arrow is you telling me that you know what direction you went to get to it.
Yeah. So like, do you have? So then, like for the coterminal, do I have to like draw? Do we have to draw it?
Oh no. I got what you're saying. If you're asked to find coterminal angles, you're just going to be asked to find the number, not draw it. It would be kind of silly for me to have you draw a coterminal angle because it's the exact same spot. I didn't realize what you were trying to ask. Okay, reference angles are what you're going to use a lot more. So my hope this year is to just give you guys a lot of different basics of trig, so that when you start doing a lot of trig, you'll understand what everything is kind of based off of, because that's usually the hardest part when you learn something, is when you're learning something new, there's all sorts of new words, all sorts of new things, and it makes it very difficult to learn a new topic if you're not even sure what's being used as like a reference. Like if the explanation is something you don't understand, then it makes it hard. So a reference angle is different than a rotational angle. Like I said, all sorts of new terms. Sometimes you want a rotational angle, sometimes you want a reference angle. Now, my definition of a reference angle might not make sense yet. That's okay. It's quite easy once you know what you're trying to do. Is that high enough for the back to be able to see? All right. Yeah.
So does that say, a reference angle is how many degrees?
Yep.
Okay.
Yep. It's my great handwriting. I went fast to get these notes done. The one thing I am extremely short on right now this time of year is time. I'm giving a test in calc today, and I haven't even printed it out yet. This is when Murphy's Law will kick in, and the printer will either break, or cloud printing won't work. Something's going to happen.
The backup plan.
No backup plan.
I'm just gonna put the test on the screen and
I'll worry about it when I run into it. I'm just going to hope that printer in the library works, or this one has enough ink left. Or I run over to another teacher and have them print.
You should be fine.
What?
You shouldn't, did that say terminating?
Yep.
Oh,
Like, do you need glasses, or is that just like too sloppy?
I need glasses.
Okay. I was going to say, I know it's not the neatest, but it's somewhat legible. I've seen your guys' handwriting. I know this is legible.
What do you say? My handwriting's nice.
Yeah. For somebody who writes with the wrong hand.
I write with my right hand.
I know. It looks like somebody wrote with their left.
I'm sorry, who's speaking?
Me?
Wait, so do you give credit off if you can't read it?
No, I just give it back. If I can't read it, I won't grade it.
said just took a point off my test because I was in a rush and she threw one of my words. The whole point off. And it was right too. So I explained to her and she's like, well, I can't trust that now. It's been 2 days after the test. I'm like, well, why
Being
didn't you
one,
check back?
being one with bad handwriting allows me the ability to read just about anybody's test. But now that I'm getting older, it's hard to read small stuff. Okay, most of you are probably done writing, it sounds like. Let's, actually, you know what, I'll probably do one first with you guys because I didn't even explain what it is. So the rotational angle for this problem is 60 degrees. Like, that's just what's drawn. A reference angle means I am only going to look at the terminating side. And with that terminating side, I'm going to draw a line to the x-axis. Bless you. If I draw a line to the x-axis, because that's what a reference angle means, I'm going to have a triangle with a 60-degree angle. So the reference angle will also be 60 for that first picture. The second picture
It's a little less graceful.
It's a very good pun. Second picture, I am just going to look at the terminating side. And on my terminating side, I'm going to draw a line to the x-axis. So on this particular one, I'm going to go up because the x-axis was above it. How big is this angle on the inside going to be? Are you trying to answer or asking a question? Oh, okay, go ahead.
30 degrees.
It's going to be 30 just because I know that 180 is flat line, and this is 30 more than 180. Now, this is the hardest part for most people. Oh, I forgot to write the rotational. The hardest part for most students is that this is not the same process each time. Like on this particular one, we took 210 minus 180. On this one, they're the same. Wherever your triangle / angle ends up, it's different for each problem. You just want to figure out how big the angle inside that little triangle is. Go ahead.
So for this problem, how do you know to go to the left instead of to the right? Because like there's an x-axis on the right. I get that the left one is closer, but does that make sense?
I mean, how come I don't draw it like that? Well, it wouldn't make a 90-degree angle, I guess.
Does it have to be one?
Yep. So our goal, you're always just going to go to the closest one. How's that? Is that like an easier way of saying it? Yep, it's always the closest one. Why don't you guys? I'm gonna have a long day if I can't speak now. Why don't you guys try to draw and figure out the reference angle for the third picture, and we'll call on somebody to see if they can.
I have do you have to draw the triangles, or is that not required?
Not required. I mean, like, can you just figure it out in your head? Yep.
Okay.
Yep, you don't have to. I'm drawing the triangle because I know a lot of people would like to be able to visualize it on what you're doing. But no, you don't have to. Diego, whenever you get a chance.
I'm lost.
I didn't ask anything.
I know, but weren't you asking me?
Yeah. Okay. Any particular part I can help you with?
Figuring it out, like the angle, literally everything.
Okay. How about drawing this little green triangle? Are you okay at that part?
Yeah.
Oh, okay. So how would I draw this one? Where would I make the next line? Perfect. Okay. So then what we're looking for is that angle right there in the triangle. The angle that's like right on the origin. And I'm thinking what you're having a hard time with is it's different for each problem. Like when I'm looking at this one, I know that a full circle is how many degrees? 360. But this one was 315, so I know that there's a little bit. For this one, I would do 360 minus 315. I'm sure some people in here would do 270 to figure out how far over it's gone, whatever. It can be different for every person. But that's what I would do as well. So 360 minus 315, I think, is 45. Okay? So then this is going to be a 45-degree reference angle. You're just basically going to have to use logic to figure out the angle each time because it's different for every problem. And I purposely only did positive rotational angles on this one because I didn't really want to throw you off. But when you do negative rotational angles, it's not always going to be the same process. Like you're not always going to subtract, like it's different for each problem. So that's where the logic comes in. And some people really dislike that. Some people really like every problem to be the same. The higher up you go in math, the less that the problems are the same repeatedly. Like after a while, you'll never have the same problem twice. And that's where it starts being difficult for some people. Especially Alex, who's looking up every answer on the phone right now. He's probably trying to find out how much it is to deliver protein bars. I'm surprised you didn't DoorDash it. To DoorDash it to the school? What kind of protein bars are you buying? Oh. Now, you don't necessarily need to draw this, but I think some people it might help them. This is what I do in my mind. Is I know that the reference angles, reference triangles, make up a bow tie. So if your angle finishes in quadrant 1, you're automatically going to go straight down to the x-axis. If it's in quadrant 2, you would go straight down to the x-axis. Quadrant 3 goes straight up to the x-axis. Quadrant 4 straight up. So in my mind, I know that reference triangles, reference angles make up this bow tie picture. And so when I am drawing them, I know it has to be one of those 4 corners. And you don't have to do this. I just wanted to put this up here because I traditionally like to try to explain how I do a problem in my head or what I'm thinking to figure it out. And this is kind of it. Now it can be a flatter bow tie, it can be a wider bow tie, whatever. But it's got to be one of those 4. Some people also like to call it a butterfly. If you get really bored, you can. No. Isn't that like a butterfly? What does a butterfly have, a body on the back?
Yeah, they don't have a head.
They have a head?
No, well, I would assume that they would, because I feel like they have eyes to see.
Dragonfly, sure. Sure.
Dragonflies
That's my art skills put to the effect right there.
Dragonflies are scary.
Well, they're only scary if they bite you.
They don't bite, do they?
Yeah?
They do?
Yeah, they hurt.
I'm gonna have one bite. They're just loud.
That's because they usually get scared away right away.
I always find the dead ones in my room. Dragonflies. Oh. The ones that you can see.
Okay, I believe this is the last problem.
I didn't know that they bite. I'm scared.
They don't bite unless they think you're going to kill them.
Anyway.
Let's not draw the butterfly. Okay. That didn't happen. What? It was really bad.
He was cute.
Oh,
We want justice for the butterfly.
okay.
Yeah, he should be Todd.
I feel like I need to, it just doesn't look right.
That's beautiful.
There we go. There we go.
Now it's kind of like a bee or something. I don't know.
And this is your back.
Okay. So this is going to be the type of problem you'll get that is a combination of rotational angles and reference angles. And so there's a rotational angle that you're not told. Like you don't know how big it is. But you know the rotational angle goes through the point 4, -5. Like maybe there was some sort of a measurement that you were able to take. We're going to figure out sine, cosine, theta. No, sine of theta, cosine theta, tangent theta of that angle. I'm having problems talking this morning.
It's okay.
Is that from like Hannah Montana? Or
But at least I made it here on time.
Oh, everybody makes mistakes. Everybody makes
You
mistakes.
get paid for that.
What?
I hope you get paid for
Miss
getting
Hannah Montana.
What?
No, I was called Hannah Montana in 6th grade by Mr. Kimmel because I had sparkly shoes.
I like how you think people don't show up to work on time or late even though they get paid for it.
Where are you getting this Hannah Montana
Oh, I know
from?
what you do. You don't do that job very well.
How is coming to school any different than getting a paid job?
You don't get paid.
Yeah, but you're getting it for free instead. As soon as you graduate, then all of a sudden the school costs a lot of money.
Ooh, I'm getting a
That's what I was about to say. I was gonna say I
He's
thought
still
he was
there. If you look at the DPL, he's still there. He looks creepy.
Okay, most of you should have this written down now.
Yes.
No? Okay.
I did.
Diego. Yep.
Row 1, seat 5.
5. Santiago. You got rolled. Hmm? What? How do I say it properly?
It's not shiny. You can't see it.
Okay.
I had labeled it as if
Can you give me any help on how to draw the reference triangle?
He's gonna hit you with a stone back.
Connor. Perfect. So I'm just gonna go straight from this point that's on there, and I'm gonna draw straight up to the x-axis, and that's gonna create this little reference triangle, which we're gonna use to figure out sine, cosine, tangent.
Are we assuming any angles?
We don't know the angle size. That's what you're asking, right?
Yeah.
Yeah. We don't know the angle size, so that kind of leaves us. Rather than me rolling somebody and like directly asking, because this is the step that can be hard to figure out. How do I figure out sine and cosine and tangent if I don't know the angle? Okay, but I've got no numbers.
Well, you just have the chart, so you know that one side is gonna be.
Perfect. So because it goes through this point, we know exactly how far that it's moved. It's gone 4 to the right and 5 down. And yet it can have negative values. Because it went through this point, we know exactly how far it has moved to make that triangle.
You also have a 90-degree.
Oh, you're trying to say for Pythagorean theorem? Yes. No, that's perfect. So because we know 2 of the sides, we can figure out the third side. So off somewhere else, the scratch work, I'm going to do this to figure out the third side. So C is what I'm actually trying to figure out. So 4 squared plus negative 5 squared. Now, normally it would be plus or minus, but we can't have a negative hypotenuse. So here's one of the weird things about the triangles that I've always found kind of strange. The legs of a triangle on a graph can be positive or negative. The hypotenuse is only allowed to be positive. And the only reason I've ever been given or heard is that because the hypotenuse is a distance, where these aren't distances. Did I write 45? Is that what you're trying to tell me?
I just whispered that to her. I was like, why didn't you?
Yep. I've told you guys a lot of times by now that when I'm talking and writing, it doesn't always go together. Yep.
So if we're using the bigger what makes us like able to use -5 instead of a regular number, a regular positive number? Like why are we able to use negative?
So you're talking about why can the legs be negative?
Yeah.
So the only reason I've ever been given is that the legs are considered positive or negative because it's just telling you which direction they're going. Rather than it's standing for a negative number necessarily, the negative refers to like where it's drawn, like direction, rather than like a length. But the hypotenuse is always going to be positive because it's not a direction so much. It's kind of a strange setup. The legs can be positive and negative, the hypotenuse can't.
Isn't the hypotenuse always going to be the biggest side?
Yep. It'll always be the biggest number.
How would you ever square more than side?
Square root of 41.
Oh, that's just 41?
Yes.
Oh.
Can't handle me not drinking 24 ounces.
You're right.
It's like
That's, otherwise it'd be 2.
No, yeah, I thought the box.
Yeah, that's what I figured. Okay, Diego, now somebody can help me.
Row 2, seat 4.
2, 4, who is that? Hadley? Okay. Hadley, how do I... What?
Did she already get rolled?
No. No, Brianna went. It was close. You probably scared Brianna because she didn't want to go again. Hadley, how do we figure out sine of an angle? If you can't remember which sides, look up on the whiteboard. Yeah, which one? Perfect, yep. So sine is opposite of hypotenuse. So our angle is right here. That's the opposite side. Hypotenuse is always the long one. So it's going to be -5 over square root of 41. I don't have much room. Okay, how about cosine now?
It would be 4 over square root of 41.
Perfect.
And tan would be -5 over 4.
Perfect. Coming up with the final answers isn't going to be too bad. It's all of the work leading up to the final answers. That's nothing here is individually hard. It's just a lot of new things. Okay. Well, I don't think I have any more notes, and I didn't want to necessarily like push the limits of your brain today alone. Go ahead.
Do I never have to solve the square root of 41? I know it's not a perfect square, but like if it does.
You can. I'm usually not going to, just because it's less work, to be honest. So using the calculator to figure out the decimal is more work than me just writing that. Yeah. Okay, so again, I will give you guys the homework. Actually, I could probably give it to you on Thursday, and then you guys can just work on it Thursday in class. No need to bring it home, and then finish it Friday in class. And then Tuesday, I'll have a review for the test.